Hello everyone, my name is Varad Daoo and I am a doctoral student at the Department of Chemical Engineering at IIT Kanpur. I welcome you all to the first lecture of this class of this chapter, that is structure of atom. So this is uh, a class 11 second chapter of chemistry of NCERT syllabus. So I'm planning to cover this chapter into 12 weeks or 12 classes. Each class will be 1 hour class, and in each class I will be teaching concepts, so concepts, and then concept based questions, which you can also say as DPP, daily practice problems. So this I will be giving at the end of each class, uh, which you have to solve and come in the next class, and if you have any doubt you can ask me. So with this, let us start. Okay, so structure of atom. Okay, so everything around us, whatever you see, those are living beings or non-living things, a piece of wood or a piece of metal or a stone, or even the dress which you are wearing or the food which you are eating, everything around us is made up of some fundamental particles, right? So you can think it in this way, that you take, let's say for example, you take an iron rod and you break into two pieces. Again, those two pieces can further be broken down into two pieces. These two pieces can further be broken down into two pieces, right? So a point comes wherein this we cannot break down. A point comes where a material or a substance cannot be further broken down. This is what is called as the Greek word for this, atomos. Greek word is atomio, and the Sanskrit word is
क्या आप सुन पा रहे हैं?
yes, yes. आप सुन पा रहे हैं मुझे?
यस, तो एक रिक्वेस्ट थी आपसे, ये जो आप इसको शायद आपने पोर्ट्रेट मोड में रखा हुआ है टैबलेट,
ओके ओके
इसको आप लैंडस्केप में कर दीजिए या फिर समझ गए ना, आप लैंडस्केप मोड में रख लीजिए। अब पढ़ाइए। अगर रेज़ोल्यूशन इंक्रीज़ करने का ऑप्शन है तो भी कर दीजिए और फिर से पूरा एक बार एक्सप्लेन कर दीजिए।
फिर से ओके ओके ठीक है।
ठीक है? क्योंकि वो रेज़ोल्यूशन हम नहीं ले पाएँगे, एक्सेप्ट नहीं कर पाएँगे इसलिए।
ये जो रिजोल्यूशन है ये चलेगा क्या? अभी मैं लैंडस्केप
अगर
करके
अगर इससे आप बेटर कर सकते हो तो ठीक है, नहीं तो इट्स ओके। अगर आप बेटर कर सकते हो तो ठीक है।
अभी तो मुझे पता नहीं है। कैन आई ट्राई इट इन द नेक्स्ट क्लास?
ओके, तो अभी आप कर जितना आप कर सकते हो उतना कर दीजिए, बाकी नेक्स्ट क्लास ट्राई कीजिएगा।
ओके
चाहे
ओके
तो और ज़ूम कर सकते हैं, देखिए साइड में मार्जिन काफ़ी छूट रहा है और
ओके
अपने हिसाब से ये बॉर्डर है ना, ये और ज़ूम कर लीजिए, बस इतना चल जाएगा।
ओके ओके
ठीक,
ठीक है
और थोड़ा-सा ज़ूम आउट कर लीजिए, ये एरो के अंदर ही रखिएगा बस, ठीक है?
ठीक है।
जो एरो, हाँ, बस। तो अब अपने हिसाब से आप कंट्रोल ले लीजिए। फिर से एक्सप्लेन कर दीजिए प्लीज़,
हाँ ठीक ठीक ओके
ठीक है? मैं म्यूट हो रहा हूँ।
ओके ओके। So hello everyone. My name is Varad Daoo, and I am a doctoral student at the Department of Chemical Engineering, IIT Kanpur. So I welcome you all to the first class of structure of atom. So this is the first class. The chapter which we are going to study is of atom. So this is a second class. This is the second chapter of chemistry of NCERT syllabus, and we are going to cover this chapter in upcoming lectures. So I have divided the whole chapter into 12 weeks or 12 classes. Okay, each class will be of 1 hour, and at the end of each class I will be giving you DPP, that is daily practice problem, and you have to solve these questions and come prepared in the next class. And if you have any doubt you can ask me, okay, at the starting of each class. Okay, with this said, let me begin. In the next few classes we will discuss about the fundamental particles that constitute everything around us, whether you see whatever you see around us, whether those are living beings or non-living things, or a piece of wood or a piece of metal or anything. So these fundamental particles are nothing but the building blocks using which the entire universe has been created. So in this lecture we will see the properties of these fundamental particles. So what we will cover: fundamental particles. What are the fundamental particles? Question mark. We learn about how they are discovered, how these fundamental particles are discovered, what are the stories behind it. So this is the scope of this class. So let us begin. So in the last 200 years, scientists have made significant progress in obtaining very clear understanding of structure and properties of the matter. Okay. So mainly the Greek philosophers and Indian philosophers have been wondering about these atoms. So the existence of atom has been proposed since the times of early Indian and Greek scientists. So what they used to think is, let's say they have a piece of, let's say, iron bar. They used to think that we can cut this iron bar into two pieces, right? As this you can do. This can further be broken down into many pieces. Cut down. Like this, we can continue until a stage of uncuttability. A stage of uncuttability is achieved, and this is what is called as the Greek philosophers. The ancient name for atom given by Greek philosophers is atomio, whereas the name given by Indian scientists is Parmanu. So in this class, so there are mainly four theories of atoms are there. Four theories of for discovery of atom. Those are number one, Dalton's theory. Second one is J.J. Thomson's discovery of electrons. Then James Chadwick's discovery of neutron. Further, Rutherford's discovery of protons, and finally Bohr's model. Bohr's model of atom. Right. So we'll start. So this will be the scope. Okay. So we will first start with Dalton's theory. Dalton's theory of atom. So Dalton's theory is the most easiest theory. According to this theory, what we have is, okay. So according to Dalton's theory, what we have is atom is an indistinguishable. Atom is uncuttable, or atom can never. Atom is the fundamental particle. Fundamental particle. All substances, and it cannot be broken down. Cannot be further divided. That means according to this theory, no existence of no existence of subatomic particles like protons or electrons or neutrons is possible. Okay. So Dalton, but however, the advantages of Dalton's theory was that Dalton's theory was able to successfully explain the laws of chemical combination. Successfully explain laws of chemical combination. Like for example, so before this, let me first. So according to this theory, we can have an, let's say, different atoms can be different. Like for example, we have a atom of iron will be different from atom of cadmium, which will be different from atom of hydrogen. Right. So we can have different atoms. Right. Hence, because of this, what it was able to do is it was successfully successfully explain the laws of chemical combinations. Like for example, let's say we have an atom type A is combining with two atoms of atom type B, resulting in the formation of, let's say, AB2, right? So this is what atom type 1. Okay, let me, this is atom type 1, this is atom type 2, and this is atom type 3. So two atom types giving rise to third atom types. Okay. However, it was not Dalton's theory was not able to explain disadvantages, unable to explain how chemical combinations, or should I say, unable to explain, unable, unable to explain the methodology or mechanism of chemical combinations or reactions. Further, it could not explain, unable to explain the electrical, unable to explain the electrical nature of materials or matter. Like even before the Dalton came, it was well established that uh, when glass or ebonite rod is rubbed with silk or fur, it generates electricity. Like for example, here we have this is a glass rod, and this is a silk material, silk cloth. So when these two are rubbed, it was well established that this results in the formation of positive charges here and negative charges here. Right? That is the concept of static electricity was well known, and because in Dalton's theory, atom is a neutral and it cannot be broken down into subatomic particles. The static electricity was cannot be explained using Dalton's theory, right? So this static electric charges was the concept of this was given by Michael Faraday in 1830, right? So according to this Faraday's law, according Faraday's, so we will do this one. According to Faraday's law of electro sorry, electrolysis. We already knew that if a fixed amount of electricity is passed through a cell, then it produces a fixed amount of a particular substance at the electrodes. So I will explain its meaning. And the other law was that the number of moles of various substances, the number of moles of various substances liberated at the electrodes by a fixed quantity of electricity are in the ratio of small integers. Okay, so what do we mean by this? For example, what we have is when 96,500 coulombs of electricity of electricity when 96,500 coulombs of electricity is passed through a cell containing pure sodium, a cell containing fused NaCl. NaCl is nothing but common salt, right? Then what happens is 1 mole of sodium is deposited at the cathode, and half mole of chlorine gas is evolved at anode, right? So this kind of a behavior could not be explained by Dalton's theory, right? So this was the major drawback of Dalton's theory, which was further. So Sir J.J. Thomson, okay. So we'll go to the next theory, that is discovery of electron. Right? So these questions could not be answered by Dalton's theory, and hence scientists all around the globe were trying to figure out a better theory which could explain this behavior. And everybody thought that atom should be subdivided, and it should have fundamental particles like positively charged particle and negatively charged particles. And this was the experiment to perform to find the electrons was done by Sir J.J. Thomson. J.J. Thomson, right? J.J. Thomson's experiment, which so this experiment discovered electrons. Yeah, this is also called as E by M experiment, or we'll discuss it later. Okay, so according to, so this was done in around 19th century. So what this, so these experiments were known as discharge tube experiment. So these experiments are known as discharge tube experiments, right? So how were these experiments performed? So what we have is, under ordinary conditions, gases are poor conductors of electricity, right? However, when a high voltage is applied to them at a very low pressure, these gases become conductors and electricity begins to flow in the form of rays. These rays are called as cathode rays, right? Cathode rays. These are negatively charged rays, right? So the existence of these rays were shown by scientists like Plucker and Crookes, but the main credit goes to J.J. Thomson's, right? Because he studied the properties of cathode rays in detail, which led to the discovery of electrons. Actually, it led to the discovery of electrons as well as E. Okay, so we'll discuss it later. So the experiment is like this. So now we'll discuss the experiment. Right. So let me first grab the image. Okay. So how this was done is, okay. So how was this done is, there was a tube like this, right? Okay. And then there was this cathode, okay, and anode, and these were connected in the circuit, right? This was negatively charged, this was positively charged, and this is connected to an external circuit, right? And this was connected to vacuum pump, right? To vacuum pump, and this was filled with gas, right? So this tube was filled with gas particles, right? So the blue one is gas particles, and to control the pressure inside this gas tube, what the equipment was connected to vacuum pump, right? And this is a cathode, okay? So this is cathode, and this is anode, okay, right? So what was done is, the when so these gas particles were exposed to uh, uh, a high voltage gradient, and simultaneously the pressure inside the tube was also varied. So the observations which were obtained from this is, these are observations were the so what basically was done. So before this, what was basically done was that the gas inside the tube was exposed to high voltage and low pressures. Okay. So the observations was that, number one, initially what was done, only the voltage was changed and pressure was kept as a normal. Okay. So when this was done is, when this was done, what we observed was that the gas remains non-conducting, right? So in words, this can be explained as when. So let me write observations. Observations. So first observation was that first observation, when the discharge tube containing gas was kept at normal pressure, that means pressure was not reduced, right? Normal pressure, nothing is observed even when the gas or the experimental setup and let's write gas only, gas was exposed to high voltage, exposed to high voltages. So voltages, when we say high, it was around 5,000 to 10,000 volts, right? And it is irrespective of the which gas they have taken, right? So the Sir J. J. Thomson had conducted similar experiments for many gases, and these are the general observations which were obtained, right? So irrespective of the voltage exposure, at normal temperature, the gas remain unionized. That is, the gas remains non-conducting. Remains non-conducting, right? So this was the first observation which was obtained. Okay. Second observation. So till now you have any doubt? Anybody has any doubt? Okay. So the second observation which was obtained was that when the, so in second observation, what was done? The pressure was also reduced and the gas was also exposed to higher voltage gradients, right? So the pressure, and what was observed in this case was that the fluorescent, okay. So the pressure, so in this case, what was in the pressure of the gas inside the tube was decreased by pumping out the gas with the help of vacuum pump, right? Okay, so when the pressure of the gas is decreased to about approximately around 10 to the power minus 2 atm, which is nothing but 1 to 10 of Hg. A different observation was obtained, which was the gas became conducting. The gas became conducting, right? So how did they observe this? Is that the gas started emitting the light, right? So how did they observe this? This was confirmed because the gas started emitting light, right? And the color of gas or color of light emitted by the gas dep- uh, depends dep- depended on the nature of gas taken, right? Now when the pressure was reduced to again 10 raised to power minus 4 atm, which is around 0.01 of Hg, what they observed was that the glow in the tube stopped, but the gas continues to conduct the electricity, right? Or what we can write here is pressure was further reduced, right? Pressure further reduced to about 10 raised to power minus 4 bar, which is around 0.01 of mmHg, right? What happened was the glow the glow stopped. The glow stopped, but the gas continues to conduct electricity. Right? Moreover, what happened was that the glass tube at the anode. Anode began to glow with a faint greenish color. Right? So how did they observe was how did they do? So what they did is here or so here what they did. So this is cathode, this is an anode. So around this end, they coated this end with a fluorescent, a phosphorus kind of a material, right? Which glows when something hits on it, right? So when the pressure, so to summarize what happened is this was a cathode, right? So this is a cathode, this is an anode. So this cathode, this thing is connected to an external circuit, right? This is a cell, and inside this chamber, a gas is present, right? And this whole connection is connected to a vacuum pump to maintain the pressure. So in this whole experiment, what is done is a gas is taken and it is exposed to various combinations of uh, voltages and pressure. So when the pressure, so initially what was done is pressure was kept constant and very high voltage difference was applied. So what happened is nothing happened. The gas remained unionized. That is, it did not conduct any charges. It did not conduct any electricity. Right? The gas remains non-conducting. Right? But when the pressure was pressure was reduced to around 10 raised to power minus 2 atmosphere, which is around 1 to 10 mm of Hg. The gas became conducting. Right? The gas became conducting. How did they notice it? This was because the gas started emitting light, and the nature of the gas uh, and the light emitted depends on the nature of gas taken. Right? When the pressure was further reduced, note that the voltage difference are very high. Right? The voltage is the same. What happened? The pressure was further reduced to around 10 to the power minus 4 bar. The glow stopped. However, the glow on the anode side of the tube started to happen, right? So this glow started to happen. So how did they know about this glow? So this outer layer of this inner layer of this tube was coated with fluorescent material, which is most likely of which is usually a phosphorus material, phosphorus sulfate or phosphorus based material, which glows when it hits, when any other particle or it was formulated, it was concluded discovery of the tube is due to due to bombardments of the gas by certain rays emitted from the cathode, right? So this was first conclusion which was obtained. Second conclusion was that these rays move from cathode to the anode, right? Third conclusion which was obtained. So further what was done is that, so let me first draw the diagram. So what was done is the flow of current from cathode to anode was further checked by making a hole So I will explain it in the via diagrammatic way in the upcoming slides. Making a hole in anode and putting the tube behind the anode with fluorescent material, that is zinc sulfide. Right. Also, when these rays passed, when a certain object is kept, when these rays are flowing, they casted a shadow as well. Right. So these rays were termed as cathode rays. Right. Because these originated from cathode and ended up in anode, these rays are called as cathode rays. So the diagrammatic representation would be like this. This is the way. Right. Here we have cathode. Here we have anode. This is connected to external circuit. Here we have vacuum pump arrangement. Right. So what happened? What must be happening is this is cathode and this is anode. So rays started to travel in this direction. Right. This was the direction of those rays, and when those rays hit this thing, fluorescent material, which is zinc sulfide, right? Obviously, this happened only when it started to glow, right? 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 So these rays are known as cathode rays. So let us now study the characteristics of these rays. Okay, nature of cathode rays. So the first is that the cathode rays start from cathode and move towards anodes. Right? So how did they confirm? How did they confirm this? Is whenever an object was placed inside the tube, it casted a shadow on the wall opposite to the cathode. So during this experiment, what was done is the gas fluorescence only in the region outside the shadow. This experiment showed that the cathode rays travel in straight line, right? And they travel in straight line. Okay. Further, since the shadow falls on the wall opposite to the cathode, it shows that the rays travel from cathode towards anode, right? So how was the experiment done? It was like this. So we again go back to our, this was our experiment. This is cathode. This is anode, right? Connected to cathode. This is anode. So when a object, let's say for an example, the object is like this, a fan blade like this was kept. So what they observed was that it casted, so we could see a shadow of this, like this, right? So this confirmed that the rays traveled in this direction, right? Like this. Also further, okay, so like this rays traveled, right? So we could obtain shadows till this point, but whereas when it passed like this, here because the fluorescence material was present in here, right? We could see a glow. Glow could be seen. Whenever the object was not object was not in between the rays and the screen, a shadow was seen. So whenever the object was not in between the rays and the screen, a fluorescence was seen. Whereas whenever the object blocked the path of rays, it showed a shadow. So this basically what does this show is this figure shows figure shows cathode ray cast a cast a shadow of the object placed in the path, right? The second observation which was made was the rays themselves are not visible to the naked eye, but their behavior could be observed with certain kinds of material. That means this material when hit the fluorescent material, they glow. That is what we are meaning by that, right? Third one would be cathode rays produce mechanical effects, right? For example, when this material, when this object, when this object, when this object was allowed to freely move, right? When it is placed on a hinge, and when these rays hit this material, hit this object started to move, started to rotate, right? This fan started to rotate when it was connected to an hinge, and these rays are allowed to hit it. That means thereby what the only conclusion which could be drawn is these rays are passing on their momentum. They are coming in contact with this fan. They are hitting this fan and changing their momentum. because of which this fan is rotating, right? Then further it was also seen, right? So this was the third observation. The fourth, this is the third nature of cathode rays. The fourth would be in. So this is very important. So let me write it with different and in absence, right? In absence of electric or magnetic field, right? These rays travel in a straight line. Okay. However, whenever electric or magnetic fields are applied, these rays deviate. Like for example, let's take a short. So here we have, right? So whenever there is no electric field, the electric or magnetic field, the rays travel in straight line, right? Like this. However, when there is, let's say, electric field, we can see that the rays deflected in certain direction depends, and the direction of deflection depends on the electric field. Let's say the electric field is like this, right? These rays go like this, right? Like this. Is depending on the electric and magnetic field, the rays goes like this, right? This was the fourth observation. The fifth is, so in this thing, okay. So the fifth one is when the cathode rays produce X-rays. Sorry, when the cathode rays are allowed to strike thin metal, foil, it gets heated up. Thus, cathode rays possess heating effects, right? Sixth observation was that the cathode rays penetrate through thin sheets of aluminum aluminum and other materials. And the last but the most important one is the characteristics of cathode rays do not, and let me highlight it, do not depend on the nature of electrodes, and nature of gas present in the experiment. Also, in the next class, we will see how E by M ratio, that is charge to mass ratio for this cathode rays, was obtained. But for the time being, you can note this down, that the ratio of charge to mass, that is charge to mass, is same for all the cathode rays, irrespective of the gas used in the tube, right? E by M, charge to mass, same, right? Right. So all these observations so all these observations led that cathode rays consist of negatively charged particles, and these particles constituting cathode rays were named as electrons. And thus negatively charged particles, right? So thus the Dalton's theory was broken down, and a new theory which could explain many behaviors was given, right? So in this class, what we have seen is fundamental particles. First of all, what we have seen is we can understand the concept of atoms. Then further, we learned about Dalton's theory, which said atom is fundamental mental particle. Then we saw drawbacks, Dalton theory, right? which give rise to the experiments of Sir J.J. Thomson. These are also called as cathode ray experiments. Cathode ray experiments, right? Then we learned about these experiments, and we learned about cathode rays, and then we understood the properties or nature. Then we learned that atom is atom is not the fundamental particle, but atom can be broken into subatomic particles, and the negatively charged particle, which consists of cathode rays, is what we termed as electron, right? In the next class, now what we will be doing is, let me write it up. This class, this lecture, right? So in the next lecture, what we will be doing is, next lecture we will be seeing that charge to mass ratio of electron. How was it calculated? What is its value? Then we will so so then we will learn about Rutherford's experiment, which its charge to mass ratio, E by M ratio, right? And then properties. So the rays which are associated with the proton are called as anode rays. Its properties we are going to study. Okay. So I thank you all for joining this lecture, and I hope you are able to understand what I am saying. If you have any doubts, please let me know, and I hope to see you in the next class. Thank you.